Hello and welcome to the October Community Hangout. I'm the community manager at Electricamp, Matt Haynes, and with me today is Tom Byrne, one of our happy engineers. So we're going to be talking about a few different things today, and I think we've sorted out most of the issues that we had with last month's Hangout, with the screen sharing and the QA. I think those were the big ones. So on the side of your YouTube channel, you should see a little place to ask questions, hopefully. And you can also ask them in the forum thread about the Community Hangout or on Twitter with the hashtag #ImpLive. You ready, Tom? Excited?
Yeah, although it does say comments are disabled for this video. That might not be the same thing.
Awful.
We're still figuring out Q&A.
All right, so hopefully that works. We will see. In the meantime, the first thing we wanted to do was give a big congratulations to OrbNext. Everybody at Electricamp, or most people at Electricamp, are always super excited and interested in what Kickstarters are going around, and even more interested in ones that have the imp in them. And so every time a Kickstarter ships, there's always some joy. And when a Kickstarter ships with the imp in it, there's some added joy. So this is the OrbNext that Tom's holding. It's basically a little ambient cube that you can hook up to if this then that, or have a few different triggers built into it. I just opened mine about a week ago and I've played with it a little bit. Lots of people have been sort of asking why is it so expensive? And when you pick it up, I mean, if you have one, you've probably already marveled at the beautiful glass it has. It's like hefty.
It's quite well made. Yeah.
You could probably hurt somebody with it, but I don't think you'd want to do that.
Yeah.
So let's see. I'm gonna pull out my handy dandy mobile app for it and see if we can get it doing some pretty color things. So some of the things you can have it do is just cycle through different colors.
I just can't not smile when it fades in like that.
Yeah, it's really nice.
It's really pretty.
We can pick sort of a specific color. I know Tom likes blue, so let's make it blue. And it can just sort of act as a lamp. Let's see, we can have it hook up to the current temperature. So it's a balmy 90 Fahrenheit or 32 Celsius in Los Altos today.
Really?
Apparently. So that's why it's kind of angry and red. We can hook it up to today's UV index, which is also high, probably because of that nice temperature. We can have it track some specific stocks or the Dow Jones thing, or as I mentioned, hook it up to IFT. So right now I have it hooked up so that whenever somebody submits any kind of GitHub issue against any of my repos,
oh, nice.
It'll start up and glow. So hopefully I won't do the horrible thing of going like a month without noticing notifications.
It's a nice little not on your screen.
Yes, nice little
notification.
Yeah, so actually I'm going to show off this a little bit later as well. This goes along with the ambient displays, but we'll talk about that one in a tiny bit. Did you get an OrbNext?
I didn't. No.
I know there's a lot of people in our community who have them. If you have one and you've played with it, I'd love to hear what other people think. This is right up my alley. This is one of my sort of not dream IoT projects, but this is one of the things that I really like. I like pretty lights and ambient displays.
I want to fill a whole room with these. These are really, really nice.
Yeah, it'd be cool to have like a big stack of them and find some way to tie them together.
Mm-hmm.
One of the questions that I know some people have asked about the OrbNext is how they can reprogram them. And this is one of the sort of disconnects that exists in the community sometimes about how accessible commercial imp products can be. So there's the sort of community free side of Electricamp, which is what most of us participate in and know and love, where we provide our platform and everything to users to build cool things with. But then on the commercial side, there's all these people like Quirky and Budweiser and OrbNext who are using it in commercial products. And when you use the imp in commercial products, you get a few extra features, including the ability to lock down the firmware. So save of sort of straight up replacing the imp or re-engineering the product. You just have the functionality that you have built into it. I'm sure at some point somebody's going to start like a imp product hacking community and be like, this is how you like rip things apart and make them do whatever you want. But then you lose all of the built-in functionality, which is kind of
a lot of times the reason you buy the product is because you want their software that they worked so hard on, and you want it to talk to their backend that they brought up for you, and all of those things.
I don't want to build my own IFT integration. I just want to use OpenX.
And in some cases you probably can't, right? Because of like the way that different parts of it are implemented or the way they've hooked up some of their backend. And that's what's I think so neat about this is that their product is an open-ended product that you can kind of add on to. So
it's cool having the IFT integration. That's another thing a lot of people ask us about is when are we going to get an IFT channel? And all of our conversations with IFT always end up with our platform being a little bit too open to specify.
Not even a little bit. It's a lot too open.
To specify some kind of specific channel.
Yeah, we want an IFT channel for computers.
Yeah, so we're excited for the day when IFT might eventually release a generic webhook channel, but I'm not holding my breath for that. But when you have a specific product like this or like the quirky products, you can build a channel.
Sure.
It just sort of takes starting a conversation with IFT.
IFT was really into it too. I remember talking to them a little bit as they worked through getting this integration up and running for the first time. And Aaron, one of our engineers who sometimes appears on our community hangouts, was pretty heavily involved in getting that up and running. And they were super helpful. So if you're out there starting your Kickstarter and you want to connect your electric imp product to IFT, it's been done and it's a good time. So,
there's resources, there's a bit of a knowledge base, and it's definitely growing.
Yeah.
So I'm going to turn it over to Tom now to talk about some exciting, cool new hardware.
Oh, okay.
I was going to let you use the camera on this other computer that we have here, but while you're talking about hardware, I'm going to see if I can fix the QA.
Okay.
And if not, just revert to forums or Twitter.
I'll just cruise on up here and show it off a little bit. So one of the things that we've been working on quite a bit lately is making the Info 02 more accessible to developers. The whole idea initially was to have a better resource for people working at hackathons, a better starting point so you could pick up a board and just run with it and you wouldn't have to spend as much time doing things like finding AND gates so that you could talk to 5-volt logic or something like that. But what that actually wound up turning into was, it would be nice if we had a board that was just generally good at showing off the things that you can do with an imp, especially with an Info 02 where you've got 6 more pins. So that's kind of what this has evolved from. This is the latest draft, Rev 2, of our INT 002 evaluation board, EVB. This isn't available yet, but we're working on getting to the point where it becomes something that you can go and buy. What we have on here is actually a lithium-ion battery pack power supply, so you can actually recharge the lithium-ion battery while it's attached to the board, or you can not install a lithium-ion battery and run without one. It's got a 5-volt boost and a 3.3-volt LDO on it, so you can actually power up, say, NeoPixels or other 5-volt devices off the 5-volt rail on here. We've also got a number of features that you can plug in and use. So there's 2 rows of pins, actually. If we look at the board nice and close, this line right here is a row of headers that you can plug wires or pins into, and then down here we have the normal row of pins that you can plug into a breadboard. And if anybody's old school and played around with like Moog synthesizers, this is kind of like the Moog synthesizer of the electric imp world. You patch the pins from the imp to the functions that you want. So think like an I/O expander, except you do it with a wire. And that gives you access to a number of other features that are basically like little breakout boards that we've built onto the board with this. So you have a buzzer, you have a Hall sensor, so you can sense magnets. It's got a 3.3 to 5-volt translator. It's actually just an AND gate. 5-volt to 3.3-volt translator. It's just a buffer. So you can actually hook up UART, talk to a 5-volt device without having to worry about being 5-volt tolerant. Or you can drive a large array of NeoPixels without having to worry about doing a translator or bringing the voltage down on the NeoPixels. There's a lot of different things you can do with it that we've kind kind of struggled to do easily before.
Have you mentioned Arduinos?
Yeah,
That's
you
the
can.
other cool one. Reprogram Arduinos.
Sure. Yep, with nothing but what's on this board. You don't need any extra parts because you can use the translator that's already here. You patch in the UART to the 5-volt translator, patch that to the Arduino.
I think you hook up like 3 wires, and
you
then
need the TX, RX, and the reset line.
Yeah, and then there's some code that Aaron's written for basically uploading a hex file, a compiled hex file of an Arduino sketch, and it downloads it, chunks it, and then reprograms the Arduino.
Yeah, we've actually been working on libraries to do that for a number of different types of devices. So we have an STM32 library now, so you can reboot your STM32.
And that's what's actually inside of the imp as well,
isn't
it?
Yeah, it's actually, yeah.
So you end up with 2 STM32s in your project, and
yep.
one of them reprograms the other one?
Yeah.
That's pretty cool.
Yep. So there's a lot of different things that we're working on like that, but probably going to do one more revision of this before it's widely available, but we're looking at it's probably going to get smaller than this by a little bit, and we're working on improving the power story a little bit and just making it really clear and easy to use without having to read a ton of documentation. So stay tuned for that.
Yeah, and then do you want to talk about the super secret preview of maybe this is a thing that might happen?
Are we talking about them?
Yeah, we are.
Oh, cool. So yeah, I think kind of to the same
hold
end.
It up and be able to guess.
To the same end as the Info 2 UV. Another thing that we'd really like to do is make it easier to plug devices into your breakout board, your Info 1 breakout board that you can get from SparkFun or Adafruit or us or DigiKey, and immediately just pick up some code and go and do stuff with it without having to worry whether or not your hardware is working properly. So we're working on what we're calling tails. And these tails just plug right into your April. Do you have one I can plug it into?
I don't have an April, actually.
All right. Well, this would plug right into a row of pins on the end of your April or your Info 1 breakout. And this one happens to be an IR transceiver tail. So we have 2 buttons, and then we have an IR receiver and an IR got it backwards. Yeah, an IR receiver and an IR transmitter. So a little IR LED and a little IR phototransistor. And they're hooked up to a UART on the amp, so you can send stuff back and forth over IR.
So we've made a bunch of these, and we're going to be using them in some upcoming workshops and see how they work. And we're hoping to take this idea of tails, which are kind of like Arduino shields, but for the April, and run with it and see what kind of other things we could put onto a tail to make things easier.
We have some ideas.
So we've talked about a weather sensing one that would have your temperature, humidity, barometric pressure, and maybe a hookup for the SparkFun weather station. We've talked about a 9 degrees of freedom one with a gyro accelerometer.
And a magnetometer.
Magnetometer, which is a compass chip, I guess.
No. No. A magnetometer, when properly calibrated, can be used to derive some measurements that act like a compass. It senses magnetic field.
So like a compass chip?
Yep.
As well as maybe some pretty LED ones and some other things. And we would love to get your feedback on what kind of tails you would like to see. We're really good at coming up with ideas, but we're all crotchety old engineers, and we tend to overthink things. So we would love to have your feedback. Post it on the forums, tweet at us or whatever, and let us know what you think of the idea of tails and what kind of tails or add-on bars you would like to see. I think the QA or chat should be working now, so if you refresh your video page, you should get a little chat window, assuming we have done things correctly.
Yeah, it works.
Cool. All right, so on to showcasing some projects for the month. So most of these projects are coming from a great hackathon that we attended last weekend called Silicon Chef. It's run by Hackbright, which is a women's code school in San Francisco. And I was traveling, so I wasn't able to attend, but Tom tells me it's one of the more creative and excellent hackathons that we've been to.
I had such a lot of fun there. It was such a privilege to be able to go and work with the people that were there hacking on projects. Saw a lot of stuff that we hadn't seen before.
Yeah.
One thing about going to hackathons is you do start to see a lot of the same projects show up over and over again, and a lot of these were totally fresh, so it was cool.
Yeah, so I'm going to share my screen and some pictures. Unfortunately, we don't have demos of them, but the two projects that I'm going to show off today, I think both teams have promised to write blog posts, or we're hoping they'll write blog posts at least. So give me a minute to share my screen here.
I know that both of them definitely took a lot of photos and were constantly documenting throughout the process, which is actually quite a bit of work. So I would be very surprised if they don't actually get around to posting that.
Yeah. All right, so this is the first project. I like this project for two reasons. So this is a this is like a arrival time indicator for buses or anything else, I suppose, but they hooked it up to the bus schedule. So there's two things that I really like about this project. One is the Fibonacci spiral, so that you get like more stressed out as the bus gets closer. It's like it lights up in a ring as it gets closer to the bus showing up.
Yeah. Well, the buses are actually, you can see, think of it as a roadway, and you can see how far away the buses are based on which LEDs are lit. So right here, I think we're looking at 3 different buses.
Oh, I see. That's cool. So actually, before I moved to California, one of the companies I worked at did real-time bus locating software for the city that I lived in, and this was like 6 or 7 years ago. They were running on these like tiny Linux machines that we built from scratch, and they had like horrible Python and PHP scripts. And it's come a long way since then, but I would love to hook this up to that or anything else that doesn't just sort of do predictive or scheduled bus times, but like actual physical distance away from you.
Right, yeah.
The other super cool thing about this project, which I'm hoping they write a bit about in their blog, is that they have 30 LEDs in this spiral, and they're not using any extra hardware.
Yeah.
So they're doing a thing called Charlie plexing, which is a way to control many LEDs with a few pins. So with the 6 pins from the imp, they're able to control the 30 LEDs.
This is a close cousin of keyboard scanning, which is a way that you can read like a membrane keypad with fewer actual pins than you have keys, where you scan across and see which nets are connected to which other nets, and that tells you which button in a membrane keyboard is pressed. Charlie plexing is kind of like that, except the other way around.
So instead of just having your LEDs hooked up to like your source and ground,
right,
each LED is hooked up to 2 separate pins,
right, which are crossed in a matrix.
And then combinations of pins being on or off or tri-stated and floating causes different lights to come on.
Mm-hmm.
That would actually probably be a really cool thing to have a blog post about, specifically about Charlie plexing, because it's a really cool technique. It allows you to do some neat things, and you don't need to use neopixels.
The key to understanding Charlie plexing is understanding that an LED doesn't have to be on 100% of the time for it to look on to a person. So if you scan through the whole network of LEDs many, many times a second and light the ones that you want to be quote-unquote on for some percentage of that scan, it will appear on all the time, right?
I know there's a lot of problems with like bleed through with Charlie plexing as well, where if you have certain sets of LEDs on, other ones might be partially on. I'm pretty sure. My Charlie plexing knowledge is definitely not very much. So this is one of them. Was this one of the projects that you helped out with, Tom?
Only a little bit. I swung by this table a couple of times. There were actually 2 things that I really like about this too, and I don't think either one of them overlap with yours. One is that it's beautiful. I think this is super, super pretty, and I could totally see this. You know, a lot of cities and municipalities are putting in bus shelters that are more and more designed, where they like bid for that kind of thing, and the roof design is different, and the seat design is different. And I feel like actually having real transit times in a way that actually complements the art of the shelter could be like a really cool, distinctive thing about your town. The other thing I really like about it is that you don't have to be able to read in order to understand when the buses are going to show up if this is your transit times indicator. So I think that's a big win for accessibility. Great for like a place where people are from a lot of different places and don't necessarily all read the same alphabet or language. So.
Very cool.
Yeah, nice work.
The next one that I want to show off is getting into the Halloween spirit. So this project was called Scareboo. This is my favorite project that came out of it from all the different projects that I saw. So this is a little skull with a camera in one of the eyes, and it's connected to another imp somewhere else that causes this incredible thing to happen. And they took a video of it. So the idea behind this was to create a photo booth where you try and capture pictures or images of people who have just been scared. So what happens is a spider drops from a trap above you, and as it falls on you, the skull snaps a picture of it. And so there's a couple things that I really like about this. One is that we're well into Halloween season, with it being October 2nd now. And I think this would be a great like haunted house project or something at like a Halloween party. You probably don't want to scare trick-or-treaters that much or take pictures of them. Necessarily,
Yeah.
that's kind of creepy and dubious. But doing it for like a Halloween party would be super neat.
Mm-hmm.
But the part that's really, really cool about this project, I think, is the way that they architected it. So there's actually what happens is it uses one of the little Radio Shack cameras that outputs, I think, like JPEGs.
It's a JPEG camera, yeah.
So it snaps the picture, it chunks the JPEG probably up to the agent.
Yep.
And then the agent posts it directly to Twitter.
Yeah,
I think so.
Not quite. That was the goal. There was some trouble integrating that part of the Twitter API. Made good progress on it, right. But I think that Twitter actually had just deprecated the method. We noticed it actually when we got back that they had deprecated the method that we were working with. But this team put in a ton of work to actually extend our existing Twitter class. A lot of useful work, and I think we probably will finish the job.
And so the missing piece is being able to do multimedia tweets?
Yeah, the missing piece was being able to... There's the way that OAuth works is apparently a little bit different when you're posting media to Twitter than if you're just posting some text to Twitter.
Yeah.
They still got it working, though. What they eventually did was just got a PHP script up and running on Heroku that it was pretty easy to write the Twitter API in the PHP script because that's a published library for Twitter. So they just sent the JPEG to that and had it fired onto Twitter. And that got them over the line, no problem.
That's too bad. I thought that it posted directly to Twitter.
That was one of those things where I think if they had another 6 hours at the hackathon, it would have.
Yeah.
It was just it wasn't worth risking the ship.
I think we should put a bounty out on that.
I think we absolutely should.
So
that's definitely worth some kit.
So if somebody submits a pull request to the Twitter class that enables multimedia posting, so if you can upload images directly from an agent, we'll send you out a T-shirt and an April and some stickers and swag.
Yeah.
That'd be a good addition to that.
Yep.
And actually, this project, we have one more project that we're going to show off, but this actually leads really well into somebody posted on the forums earlier today asking about a Halloween contest, and this is something that we're planning on doing. We don't have the details worked out quite yet. But it's going to be a contest for something Halloween related that you build by the end of October. So it could include internet-connected pumpkins, costumes.
There was a really good imp jack-o'-lantern that was connected to the internet last Halloween.
What did it do?
It was it just lit up.
Okay.
But I think it lit up depending on, I can't remember what the data was from the internet. It might have been a motion detector.
Cool.
But it was cool. They did the actual imp logo as their jack-o'-lantern.
I think I saw that one.
Pattern, yeah. That'll be worth a dig up and retweet. I think.
Yeah. So I'm a big fan of Halloween. I think Halloween is a lot of fun. I'm making a really nerdy robot costume this year with like EL wire and LEDs and stuff. And I was thinking about just doing it with an Arduino. But then I was like, it'd be cool if I could like change it like change lights from my phone or something like that.
Yeah.
So I might imp that project.
Actually, your costume could be a war-driving robot because we now have enough APIs that you could wander from hotspot to hotspot.
That could be cool.
That could be pretty cool.
But so the challenge is going to be to build something Halloween related in the month of October. Share it on probably GitHub or Instructables. Make it accessible so that other people can learn from what you built. And we will probably do a draw or maybe a community vote for the best prize, and they'll get some cool swag, some new dev kits, maybe a tail or one of these fancy new EVB boards we talked about earlier.
Yeah, depending on those take a solid 4 hours to build. I might be willing to throw that one out there for if somebody comes in on the Twitter thing.
Yeah,
that's a ton of work, so I'm willing to put in the 4 hours to build you an EVB if you get that one done, but. We'll see.
Yeah.
And I'm not promising it, but I definitely would like to get them out there.
So there will be prizes, and it will be for any kind of Halloween project.
Mm-hmm.
How about you, Tom? Are you planning any internet-connected Halloween
costume
things?
or anything yet this year? I've been really busy.
That's fair.
But I really like Halloween, and I haven't fallen down on the job in 3 years now. I've had good costumes 3 years running, in my opinion.
But not internet-connected costumes.
No, not yet. So that would be the raising the bar this year.
Yeah. Last year, Tom went as a really great Ash Ketchum costume, and I've been trying to convince Tom for a year to build a Pokédex using Wolfram Alpha's API and ePaper. Tom hasn't done it yet, but that would be a good project.
It's a lot of work.
That is a lot of work.
It's a lot of work.
That'd be cool, though.
Every time, yeah, they keep adding species on me. Although I suppose that doesn't contribute to the work.
Yeah.
Right? That's someone else's job to do.
Yeah, that's Wolfram Alpha.
Yeah.
That's what they do.
I just got to build the system.
Yeah. I'm excited to see lots of PIR type applications. Throw a PIR sensor somewhere and have it send a message to blinky lights or spiders that drop or something else. I'd love to see a candy weight sensor. That one's a little bit trickier, but Brandon's blog about weight sensors and some of the data that came out of it maybe says weight sensors are more accurate than we think, especially over the course of a night.
If you're going to use it for a weekend, then you don't have to worry about it. If you're building 10,000 of a product that's supposed to live for several years, then you need to think seriously about it.
So maybe like a candy weight sensor that tracks how much candy you gave out. It looks when the bowl gets more heavy and less heavy. And calculates all of that.
That's totally doable. That's not a problem.
That would be a pretty cool project. And if anybody else has ideas, either share them or build them. We'd love to see what you guys have. See if anybody has posted any questions yet. Doesn't look like it.
No.
That's all right. And then the last project we're going to present, this is actually completely unrelated to everything else we've been talking about. It looks like our feed is not presenting what I think it is.
No, I noticed we actually didn't present the... I was just watching the feed go by here, and we actually didn't put up the bus indicator when we thought we did. It jumped straight to the photo booth. So.
It does funny things, and what you see is a little delayed.
Interesting. Okay.
I think, let's see. That should have fixed it, maybe. Anyways, we're going to keep going. So the last project, which I suppose we actually need a camera for, there we go, is this little guy. So this is a little, another ambient display. And this is some code that I shared earlier this week because it sort of came up on Twitter and then somebody was like, hey, that's cool. So this is a little analog gauge. I bought it from this giant electronics surplus store that's, I don't know, somewhere around here in Los Altos or Mountain View or somewhere. And
HSC.
HSC.
If you're a Bay Area person or if you come to visit the Bay Area, HSC is a giant garage full of crazy things that's down in Sunnyvale.
And I guess it's like kind of famous for smart people going there or something. Anyways, they just have like this bin full of old analog gauges.
Mm-hmm.
And they're great. And whenever we do an internal hackathon, we usually go there to buy various components, and then everybody ends up drooling over the analog gauges. So I bought one, and it sat on my desk for like a year not doing anything. A few months ago, I was like, this is dumb. I need to do something with it. So I put an imp inside of it. I'm driving the analog gauge with PWM. I tried to do fancy analog things with transistors, but no. PWM's easy. I just like tweaked the values. I sort of like made a little thing to see when it was at the minimum and maximum values, and found a period that worked well for it. So I just kind of tweaked it to get it to move how I wanted it to move. And then I set it up so that every 60 seconds it would make a request to the forums webpage, and it would scrape the webpage and find out how many topics there are that have unread comments in it for me. So I have this little not very distracting gauge that shows me how behind I am on forums now. And it's set up so that you can just make a GET request to the agent URL with your forum username and password, and it stores it with server.save and server.load, so it'll persist over power offs and agent restarts and everything else.
As soon as you come back, it'll load up the profile.
It's just been hanging out, running perfectly for like 2 or 3 months now. It's a really great project, and it's set up so that the agent does its thing, and then it just passes down the number of threads with unread comments in it and the number of unread comments just for the main page. So if you have more than one page of unread topics, it doesn't work, but usually it's pegged by then. So I'd love to see people use this code to build all kinds of other projects. This is sort of like maybe if there's over a certain threshold or if a specific question gets answered, it could display some things. So we're going to share that code. We'll post a link to it in the video description, like all the other things we're doing. And we could also, we can hook these kind of displays up to all sorts of fun.
Yeah, they're really, every time we go by there, we're always like, oh, we need more of these analog displays.
What should we use analog displays for?
I think we actually have a bin in the back of our lab now that's as big as the one at HSC, where we've just bought like that many of them and haven't got around to hooking all of them up.
Yeah.
But
have you built any analog gauge type projects?
No, I tend to use LEDs for stuff like that.
Cool.
I really like lights.
Yeah, lights are fun too.
Yeah.
So we have a question from Joel Ware.
Yeah.
So any update on the IMBO 3 chip antenna certification?
Yep.
Do you want to go through what that is, why we need it? And
Sure. So I think one of the background here is that modular approval is a thing. The FCC will allow you to, in certain cases, approve a module and then then use that approval when you go to do FCC testing for a design that incorporates that module. This is the way that IMPO 2 works. There are 2 different types of testing that you generally have to do: unintentional emitter and intentional emitter. That's exactly what it sounds like. Things that aren't trying to emit energy have to go through unintentional emitter, and things that are trying to emit energy, like a cell phone or a walkie-talkie or something with a Wi-Fi radio in it, will have to go through intentional emitter. An intentional emitter is much more involved and more costly, and if you have if the emitting part of your design is modularly approved, you can just do unintentional emitter testing and attach the FCC report for whoever did the modular approval for the module. So that's what we've done with IMPO 2. And IMPO 3 works a little bit differently because the antenna is not part of the module itself.
Right.
So there's a little bit more legwork that has to be done in order to get the modular approval. And the way that it works is a little bit different. And we're still figuring out kind of all the ins and outs of how to work with the FCC on this. So one of the things that we've been trying to do is get a modular approval for a couple of different types of antennas that people might frequently want to use. And one of them is a chip antenna that we identified that's pretty small and could be useful for people that are using the IMPO 3.
Mm-hmm.
So Joel's asking about that, and we are working towards that. We've sent some stuff off to a lab. We've done some actual testing, like in an anechoic chamber, and we have some boards out to fab that are going to help us continue the testing process and actually go through the FCC tests now that we've done kind of our own pre-testing to make sure that we're kind of in the right ballpark.
So the chip antenna for IMPO 3 is nice because antenna design is difficult and costs a lot of money, and
Mm-hmm.
chip antennas, they've done most of the work for you?
And they tend, well, a chip antenna, there's trade-offs, right? A chip antenna can be great because you put it down the same way you'd put down any other part, and as long as you run your trace to it correctly and match it correctly, things should work about the way that you expect. They also tend to be a little bit smaller than a PCB antenna, but they don't tend to perform as well.
Okay.
So
you're not going to get the 900 meters of range or whatever Brandon got in the range test.
Got 900 meters out, but that was a dirt road and a flat place with a really good router. But yeah, this is going to be a couple of dB down from your PCB antenna. But we're also working on a modular approval with a PCB antenna. We're doing those two things in parallel, so that you could pick the antenna design that, if everything goes the right way, so that you could pick the antenna design that makes the most sense for your design and use the modular approval for the appropriate antenna.
Cool.
So we're working on that, and we'll definitely keep you updated. Definitely keep asking.
Do we have a timeline? Do you know?
Nothing that I can give.
No. All right. All right. So we're going to go on to this month's API that we're going to show off. So this month's API is Keen.io. So I'm going to share my screen again. We're not going to do quite the same kind of live demo as we have before, but with the added bonus of this month, you'll be able to see my screen. So I'm going to turn my laptop this way a little bit. Let's see if this thing is still running. I have a little LED here, and you may or may not be able to see it because it's blinking really quickly, but it's my fake heart. So I just set up some device code to emulate this guy, which we showed off last month, which is the pulse sensor, because it turns out that if you carry around ragtag electronics like this for a few weeks while you're traveling, lots of things break and it's not good. So I was going to do a demo with this. I pulled it out of my box today and it was broken, so I'm using fake data for this demo, but that's all right. So Keen.io is a analytics as a platform company. So they let you push event-based data to their backend where you can store it, and then run queries, make pretty graphs, and they have lots of tools and guides for setting up really nice dashboards. So we're going to go through what it looks like to grab the library from GitHub. We'll show you where that is and post a link below. What it looks like to push data to Keen.io, and then how to build a really simple dashboard. All right, so I'm going to share my screen here.
They're working hard back there.
All right, let's find our IDE. So if we go to github.com/electrocamp/reference to our handy reference library where all of our web services and code for various bits of hardware resides, we can find the Keen.io library. So you're going to want to copy and paste the code from the keen.io.agent.net into your agent. And down here we can see a bit of usage. So basically we instantiate a Keen object. We just make some object. Basically, we can pass any kind of data that we want. It has to be a squirrel object. And then we just push it with this thing called send event. So it's pretty dirt simple, easy to use. Let's come take a look in here. So on the device side of things, this is my code. So every 1 second plus or minus half a second, I send a beat event, which is just to mimic the heartbeat code that I had before. And then, so we're not really going to care about that. This is the important part. We're sending basically an offset, which is how many milliseconds since we started tracking information. And then the current beats per minute, which we just calculate by how long it's been since the last beat.
Just extrapolate out.
This is a pretty naive approach, but it works for fake data. So over on the left-hand side in our agent code, I have my project ID and my API key, which I can get from my Keen.io dashboard. So I've got my project ID here. If I click on Show API Keys, that's going to show me all of my API keys, which I'm not going to do. because that has my write key and my master key as well, which I don't want to share.
That could be fun.
However, I don't mind sharing my, so this key here is going to be your read key. So if you have this API key, you can read data from my Keen.io store. So this is what would go into web pages and other things. So it's pretty accessible. And then we have our Keen class, which is wrapped up, and we're just going to ignore. So down in the application code, we create our Keen object by instantiating Keen.io with our project ID and API key. That's nice and simple. We have a little request handler that basically lets us set a user token to specify the name of the person whose biometrics we're sending up. This isn't super important. This is just sort of a nice little touch so that we could send event data from my Pulse hardware and Tom's Pulse hardware, and then we could sort of graph our heart rates against each other or other interesting things.
It'd be kind of fun, like if you're like running with a team or something like that.
Yeah, that could be interesting.
That'd be really interesting to see like the team's like level of effort over the course of a workout.
Yeah.
Ooh.
So down here, whenever we get the beat message from the device, which is what happens whenever it detects a heartbeat, all we're doing is, let's see. So this local data part is sort of the important part. If inside of the object that you pass to Keen, you create something that looks like this, where one of the fields is Keen, and inside of that is a timestamp formatted in a very specific way, then you can use a lot of very cool built-in functionality in Keen for querying. You can do things like, say, give me the results from the last hour instead of saying, give me the results where this field is greater than this value and less than this value.
Yeah, they have like all these very human-readable flags you can use to select different data ranges.
Yeah, and so the format they use is kind of annoying. You can see it down in the logs. It's year, month, day, T, hour, minute, second, point, milliseconds if you want Zulu.
That's not so hard once you know what it is.
Yes, but it's annoying to do.
Yeah.
So the Keen class actually has a get timestamp function.
Is it really Zulu?
Yeah.
That's awesome.
Where you can pass it a Unix timestamp, so which you can get by the time function in the agent or the device, and then an optional parameter for milliseconds, and it will format everything. And then we're also passing the beats per minute and the user, which is the name. So this is the object that we construct. To send it to Keen, all we do is we say send event, and it takes 2 or if you want 3 parameters. First parameter is the collection name. So collections are just what they sound like. They're logical collections of events. So a single account can have multiple collections. I could have a collection for biometrics, like I do. I could have another collection of unrelated data about maybe like website statistics. Another one about maybe like events for whenever the power went out in my house that I could do analytics on. So we just give it a name, the object that we want to send to Keen. And then this is set up in a way that we've been setting up a lot of the API wrappers, where all of the functions that make requests to the external API have an optional last parameter. And if you supply it, it's a callback function, and it results in it being an asynchronous request. And if you don't supply it, it makes a synchronous request. So it'll be blocking. So we have our callback function for what it does when it's complete. And all it does is it logs the response. So if I come over to my Keen dashboard, I can do things like look at the last 10 events. You can see these are all spaced roughly a second apart. And this is just because I'm sending roughly one beat per minute worth of data, which is an event every second. And if we click at it, we can see that I have this timestamp that we sent. We also have a created at as well as an ID specifically for the event. So these are created by Keen. And then the data that I passed, so beats per minute and user. The timestamp versus the created at, I think, is actually worth talking about a little bit, because this is something that comes up in a lot of data logging applications. And this is where you sort of want to always explicitly say when you collected your data rather than relying when it got to the server.
Yes.
Especially for things like this where the path goes from the device collecting the event up to the agent and then out to some other API. And that will probably be pretty quick, hopefully, if we're doing our job right. And it's typically, for me, like under a second easily. But if their stuff is slow or our stuff happens to be slow or there's a lot of Wi-Fi traffic, you might see a disconnect there of more than like 0.1 millisecond.
There's another reason that is actually really well illustrated by this application why you wouldn't want to just implicitly pick up your timestamps from when it arrives too, and that is like if you don't care particularly whether it takes 500 milliseconds for these events to arrive, as long as they all arrive about 500 milliseconds late.
Right.
But if one arrives 500 milliseconds late and the next one arrives 80 milliseconds late, or God forbid 3 seconds late or something like that,
You can have events out of order.
yeah, your heartbeat's going to look bizarre, your data goes all wonky, and that's not the real data anymore. Now you're collecting data that isn't accurate. So
the other thing we can do is we can come to this workbench. The workbench lets us run and visualize simple queries, and we're going to use this to build our dashboard. So what we can do is we're going to pick our biometrics collection. This is just what data we want to do stuff with. And then we have all of these different functions that we can do. So we're going to look at the average beats per minute grouped by user. And for time frame, this is where Tom was mentioning they have all of these really nice readable fields. So I think I can say previous hour. Let's see if I did this right. All right, so here we go. I got this weird circular graph chart that shows the average beats per minute in the past hour was 59.2983 blah 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 beats per minute, and it's doing a pie chart because we're grouping it by user. So it's if there were more than one user, if Tom had some biometric data in here, it would show what percentage of the data was mine and how much was his.
100% of your biometric data is
since it's all my data, I can get rid of that, and if we rerun this, I should get a pretty little metric thing. So this is kind of cool, and there's lots of different visualization things that you can do. And what Keen has actually done, and we'll send a link to this, is they have this great dashboard starter kit. And it looks something like this. So they have a bunch of fake data, like a Keen collection that this is talking to. And these are some of the different graphs that you can make with relatively little effort. And I modified this a little bit in about half an hour this morning to show some cool heart rate data. So I'll go through what that looks like and how you can sort of get started with this. So what we're going to end up building is something like this. Right now it doesn't auto-refresh. I'm still working on that, but we have our
this is your dashboard.
Yeah, this is my dashboard. So this is what I'm going to show you guys how to build really quickly. So we have a graph showing the BPM for the past hour. And it's averaging it with a minutely interval. So it's taking the beats per minute of every minute and averaging it, and that's what's going on to this graph. And then over here, we have the beats per minute from the last 1 minute worth of data.
Yeah, either this is fake data or you've been having about the most calm hour of your entire life. Nothing has changed at all.
This is definitely fake data.
Yeah.
So over here, there's actually, if we come back to this starter kit, there's some instructions on what you need to do to get started. You need to clone the repo, install Bower, and then do a Bower install, which just installs the dependencies that you need for it. The two files in here that are important are the index.html and keendashboards.js. So the index.html is basically some Twitter Bootstrap styled HTML, and then basically these collections of chart objects. where the important ones have IDs of like chart01, chart02, chart03, and so on, with a little thing at the top and then a little description under it. What I've done is I have deleted all but the top two. So there used to be a bunch more below here. I just wiped all of that out, and I renamed them to BPM graph and current BPM, which I didn't really need to do, but I decided to. So basically, the first step to building this like cool dashboard is just to make a bunch of these like chart chunks of HTML, which you can just copy and paste. The other file that we care about is the keen.dashboards.js, and this is what actually gets the data, binds your queries to the chart objects, and then makes it all work. So up at the top, you need to put in your project ID and read key, which are the same values that we put into our squirrel code. And then down here, there's all of these different little sets of things where they have one of these per chart. So again, I deleted all of them except for the two that I was using. And I modified it so that I had queries that I created, and then basically I just bound them to the renamed objects that I had. So getting the query is one of the sort of trickier parts, or it was for me. I think it's just because I'm bad at analytics type things.
It took me a little while to figure it out the first time, to figure out like what language that they use, like the way they phrase everything. But...
So this is one of the really cool things. So I have this query that I ran for the average BPM. If I want this to be a dashboard for me, I'm going to say the user should contain Matt. We're going to get it for the previous hour, minutely data. We'll assume that time zone is correct. All right, so now I'm getting a visualization for the average beats per minute where the user is Matt for the previous hour and grouping it minutely. So this should give me a line chart if I did this right. Here we go. So this is the graph. And the really cool part about this is over here, it'll generate some JavaScript for you. And you can just plug this into your JavaScript file, and it will generate this chart.
Neat.
So we don't need all of it, but what we do need is this keen query object. So all I've done is I've taken this, and I've copy and pasted it down into my, up into this part, and just said average biometrics, target properties, BPM, last 60 minutes, interval minutely, group by user. This is a slightly different one, but this is what we generated the first time. And then there's this client.draw, and this is what actually draws it. So there's a bunch of different chart types. You can set the title, the height, the width, and all of these other sort of little modifiers to change how it looks. And we're not going to go into that. This is more just for a quick overview of, you can take what they have for their dashboard, you can make your own queries and then modify it really quickly and end up with this gorgeous dashboard website. I'm running this just off of, like, it's just straight HTML and JavaScript and CSS, so it's just running off of my desktop or from my file system. I could upload this and everything else to like Heroku or...
Geez, so a couple of sensors, and like this is a dashboard, you could build like a building management system in an hour.
Exactly.
You know,
so that's the really cool thing. If you have a bunch of temperature sensors around your home, you could have, instead of passing like a user token or a name, you pass what room it's in, and then you have graphs for all of your rooms, and you can do some pretty powerful things with it really quickly.
Yeah.
So we've written one community blog post about this so far, about how to get started, and we're going to do a few more. One that'll look at the dashboards that we just went through, and then another looking at probably how you can use analytics in actual commercial applications. Time series data like this is some of the less interesting data you can analyze with Keen.io.
Mm-hmm.
Doing more event-based data,
right.
Things like maybe when washing machines start and stop. Would be a cool one, whether it's running or not.
Yeah.
How often the kettle in our office kitchen is used could be a neat one. We could see when people make tea, how much tea is made. tie that into some other projects. So that's it for. Whoa, that's not what I wanted to do. That's it for Keen.io and for everything we had planned for today's Hangout.
One last scan for questions
if
here.
you have any last questions, now is your chance to ask them. And we also wanted to announce, last Hangout we mentioned that somebody who used the USB host, Pulse Sensor, or PubNub library and shared a project was going to win. So not a whole lot of people did that. However, one of our forum users, Digital Archivist, used it for, he took the keyboard host that Aaron had written, plugged an off-the-shelf USB reader into it, or sorry, not USB reader, barcode scanner, or RFID reader that just outputs it as a keyboard.
Okay.
Some cool device, and he got at least one or two other forum members interested in that. So we're going to get in touch with you if you're watching, and we're going to send you out a C3VO board, which is one of from MakeDeck. So it's one of the boards available from MakeDeck. It's a module-based board, so it's got 12 pins and a LiPo charging circuit on board.
Yeah, it has a lot of the good stuff that's actually getting into the Evo 2 EVB design. That's a good board. I really like having those around.
Yeah, I have a few of them kicking around in projects now.
Every time I buy some, every time we get some, I just use them immediately. Though.
Just hoard them into your
drawer. I build them into
drawer.
stuff because it's like, wham, there it is. Battery's done. Everything just works the way I want.
Yep. So our next Hangout is going to be, I believe it's November 6th. I'll just double check that. Next Hangout is going to be November 6th. There have been some people ask if we can do it earlier to make it more accessible for all of the folks over in Europe. So we're probably going to alternate between doing them earlier in the morning and in the afternoon. So next month will be sometime in the morning on November 6th. And we're going to be talking all about Bluetooth. So we've hooked the IMP up to probably half a dozen Bluetooth modules.
Every Bluetooth module you can buy, we've tried hooking up the IMP to.
We've made some reference designs. And so we're going to share some of that work, some of the applications, and I guess maybe just talk about some of the cool things we've seen, some of the tricky bits of Bluetooth. And maybe give away a Bluetooth board, but probably not.
We'll see where we are in a month.
Hopefully. It depends. Are they a difficult build?
No, they're actually not that bad. Right. The hardest part about using a Bluetooth board, which is what we'll probably talk about next month for quite a while, is actually programming the Bluetooth chip.
It's actually using the Bluetooth board.
Using the Bluetooth portion of the Bluetooth board is the hard part of Bluetooth. Yeah.
So we'll talk about that. We'll probably do a demo, wrangle somebody into doing a live demo for it.
Oh yeah.
And show off some of the work there, because that's definitely one of the things a lot of people have been asking about. And if possible, I'm thinking we'll probably have a demo for an off-the-shelf Bluetooth module, so that you don't need one of our reference designs.
Yeah, and I mean, a lot of the stuff that we've done, we started by prototyping, just hooking the IMP up to a couple of things you could buy from Embedded Masters or SparkFun or things like that. So we can talk a little more about that next month.
Yeah, so tune in next time. We'll be talking about Bluetooth. We'll be giving away a prize to somebody who built a cool Halloween project, or maybe multiple prizes, and more. So thanks for tuning in.